So this video is continuation of the first part in this assignment. And so we're going to continue to look at functions, find their inverses, and see how their graphs are related. So let's try this one. Might be a good idea for you to try this one on your own. Can you find the inverse of this function? You can pause the video, try to work it out on your own, and see if you're right when you turn the video back on. Hopefully you've done that, and probably the first thing that you should have done is if you made the f of x y, we know that now to find the inverse we just switch the x and the y around. And so as I find the inverse of this function, I'm going to have, instead of y equals, I'll have x equals, and then in parentheses it's going to be y plus 2 squared minus 1 squared. And so now what I want to do is solve for y. So I'm going to start by adding 1 to both sides. So on the right hand side I will have y plus 2 squared, and on the left hand side I will have x plus 1. So now what I want to do is get rid of the squared, so I'm going to take the square root of both sides. And so on the left hand side I'll have y plus 2 equals, and it's going to be the plus or minus of x plus 1. But I still don't have the y by itself. I'm going to subtract 2 from both sides. So I will have y equals plus or minus the square root of x plus 1 and then minus 2, which means I can write it with the inverse notation. The inverse of x is going to equal plus or minus the square root of x plus 1 and then minus 2. So this is what the inverse of our original looks like. And so we want to graph both of these. If I were to graph the first equation, you could, if you're not familiar with how to graph these functions, you can make an x and y table. Probably one of the first things that you might want to do is plug in a negative 2, because if you do plug in a negative 2 in the original function, you're going to have negative 2 plus 2 is 0, 0 squared is 0, and then 0 minus 1 is negative 1. So this is negative 2, negative 1, which is this point. Then you'd probably want to plug in numbers around negative 2, like negative 1 or negative 3. And let's just try negative 1 first. Negative 1 plus 2 is 1. Squaring it, you still get 1, and 1 minus 1 is 0. Same thing if you plug in negative 3. Negative 3 plus 2 is negative 1. Negative 1 squared is 1, and 1 minus 1 is 0. And so we're going to have a point here at negative 2, negative 1. And then we're going to have a point at negative 3, 0, and negative 1, 0. And if I could just, using just those 3 points, probably would want 5 points in class. I'm going to have a parabola that looks something like that. So let's say I want to graph the inverse of this function. I'll do this in green. And again, I can make a table of values here. But hopefully one of the things that you've realized now is that the x and the y are just going to be flipped around. And so I'd probably want to start by plugging in a negative 1 for x, because negative 1 plus 1 would give me 0. The absolute value of 0, or the square root of 0 is 0, and 0 minus 2 is negative 2. That's going to give me a point here at negative 1, negative 2. Then I can plug in 0 for x, and I'm going to get two different answers. 0 plus 1 is 1. The square root of 1 is, let's say it's positive 1, and 1 minus 2 is negative 1. Or if I plug in 0 and I take the negative square root, then 0 plus 1 is 1. The square root of 1 could be negative 1, and negative 1 minus 2 is negative 3. Well, that's going to give me these 2 points here, 0, negative 1, and 0, negative 3. And if I use these 3 points to graph my parabola, you can see my parabola is going to be the green one. And just like we talked about before, if I have this line that y equals x, and if I drew it accurately, then you could see that those are reflections of each other. And so we have our inverse function. Are they both functions? And hopefully now you can see that the original function is a function because it passes the vertical line test. But the green one, the inverse, is not a function because when I plug in a number like 0, then I don't know if it's going to map onto -1 or map onto -3. So the answer to this question would be no, they are both not functions. Let's move on and take a look at proving whether or not two functions are inverses of each other. So I'm going to propose that the g of x function is the inverse of the f of x function. Well, you know how we talked about how the inverses undo the original function. So if I had something like this, and I had the f of g of x, then what this would mean from our composite function a couple of days ago is I would take x and I would stick it into the g of x function, and I'm going to get what I would call the y back out. Well, then I would take that y and stick it into the f of x function. But when I stick it into the f of x function, if they are inverses of each other and the g of x function maps x onto y, well, if they are inverses of each other, that would mean that the f of x function would map y back on to x. And so what this should equal is what I started with, which is simply x. And I could do this with specific, with variables, or I can do this with actual numbers. But let's just take a look at this. If I'm going to write an equation for f of g of x. So I'm going to go ahead and write it like this time. F of g of x. So I'm going to take the g of x function, the entire function, and plug it into the x in the f of x function. So it's going to look something like this. Because of the lack of room, I'm going to move down here. This is equal to 2/3 and then times x, but x is 1.5 x minus 3 and then plus 2. So if this does equal x, then they are inverses of each other because it would map x back onto itself. And so I'm going to distribute the 2/3. 2/3 of 1.5 is just 1x. 2/3 times -3 is -2 plus 2. And that does give me x. So whatever I stick in for this function, it's going to map itself back onto what I originally started with, which means they're functions. And I could do this with specific numbers as well. So for example, if I plug a 6 and I just pulled 6 randomly and I plug that into the g of x function, I'm going to get a number. But then if I plug that number into the f of x function, it's going to put me back at 6. And so let's just try this. 1.5 times 6 is 9. 9 minus 3 is 6. I probably should have picked a different number. And if I put 6 in over here, 2/3 of 6 is 4, and 4 plus 2 is 6. And you can see that they are inverses of each other. Let's take a look at the last slide here. It says use the graph of this information to graph the inverses of this function to graph the inverse. So we have this function, and this function is y equals x squared minus 2x minus 3. And it's asking, first of all, for the domain. What are the x values? Well, the x values could be anything. It moves forever to the left and forever to the right. So what is the domain of f of x? Well, we could say that's all real numbers because it's going to be forever to the left and forever to the right. The range of this function, you can see that it goes up forever, but it doesn't go down anywhere below -4. In other words, the range is going to be all of the y values that are greater than or equal to -4. It can't be lower than that. It has to be greater than or equal to -4. Well, if I were to look at the domain of the inverse of this function, and I really wouldn't even need to find the inverse of this function, what I could do is I could take a look at all the inverse points. So for example, we have this point right here, which is the point -2, 5. And if I switch those around, I'd have 5, -2. That's going to be mapped with that point right there. Then I have this point here, which is -1, 0. And if I went 0, -1, I'd have this point right here. Then if I take this point, which is 0, -3, and I switch the x and the y around, I'd have -3, 0, which is right here. And if I continued this, if I tried this point right here, which is the vertex, that's 1, -4. Well, if I switch those around, -4, 1, I'd be right here. And so I'm trying to do this where they stay. Okay, so then this point right here, which is the point 2, -3, if I went -3, 2, I'd be at this point. It's kind of hard to see where I'm at here. But, and then let's do one more point here. 3, 0, if I switch this point around and made it 0, 3, I'd be right here. And maybe this last point as well. This is the point 4, 5. So if I went 5, 4, I'd be right here. And if I graphed all of those points, then it would look like this. And those are all reflections of each other over this line, okay, which is the line y equals x. And so now, what is the domain of the inverse function? Well, the domain are all the x values, and you can see that I can plug anything in for x, but I can't plug anything to the left of -4. It's the x values that are greater than or equal to -4. And what are the range values? Well, if you look at the red function, it's going to go up forever and down forever. So the range values are all real numbers. And so I want you to look at these because the domain and the range here just switched, just flipped. The domain of the original function is the range of the inverse. And the range of the original function is the domain of the inverse. And so, and that will always be the case with inverse functions. Which one of these is not a function? Well, f of x we know is a function because that's the blue one. That passes the vertical line test. But the inverse function is not a function because it does not pass the vertical line test. I know these videos are kind of lengthy, but I'm hoping that this kind of adequately explains a little bit about inverse functions. And then we will go over questions that you have tomorrow in class.